Hey Simran, wake up! Why are you sleeping? We have a test today.
Oh yeah.
Trig identities, you remember?
Oh yo man, I was just stuck on this one problem.
Which one? Which one are you stuck on?
I was stuck on 12B.
Yo, I'm stuck on the same question. Well, what do we do now?
I don't know, bro.
Oh, I know. Grab your iPad. We'll search up like the video on
Mom,
YouTube.
do my iPad. Thanks, Mom.
Let's go on YouTube.
Alright, so these are learning goals for this video. So by the end of this video, you'll be able to recognize and apply different identities. You will learn how to prove identities using different methods. You will learn to substitute identities into the problem based on what you are given. You will use basic identities to prove more complex identities. You will use identities to simplify trigonometric solutions.
Okay, so I'm gonna solve this trig identities question using common denominator. So we have the left side here and the right side here. So we're gonna be working with the right side. So we have 1 over 1 minus cos theta minus 1 over 1 plus cos theta. So we're gonna start off with multiplying both this. So we're gonna start off by multiplying this side by 1 plus cos theta to make common denominators the same. So you have 1 minus cos theta. We'll multiply 1 plus cos theta. And now on this side we're going to be multiplying this by 1 minus cos theta. Multiply by 1 minus cos theta. So now at the top we have 1 plus cos theta over 1 minus cos theta times 1 plus cos theta minus 1 minus cos theta over 1 plus cos theta times 1 minus cos theta. Okay, so now we're gonna add these two denominators because they're the same. So at the bottom of everything we're gonna have 1 minus cos theta multiplied by 1 plus cos theta. And at the top we're gonna have 1 plus cos theta minus 1 minus cos theta. So now if we distribute the negative sign to the brackets, we're gonna have 1 plus cos theta minus 1 plus cos theta over 1 minus cos theta times 1 plus cos theta. Okay, so now we can cross out the 1 and the negative 1, so we're left with at the top 2 cos theta over, we can simplify this to 1 minus cos squared theta. Okay, so now we have 2 cos theta at the top, and then at the bottom we can use the Pythagorean identity, so that's sine squared theta plus cos squared theta is equal to 1. So if we isolate for 1 minus cos squared theta, that's equal to sine squared theta. So at the bottom here we can write equal to sine squared theta. So now instead of sine squared theta, we can use the quotient identity, and we can turn the sine squared theta into tan squared theta times cos squared theta using the quotient identity. Sine theta over cos theta is equal to tan theta. So at the top here you can continue on and write 2 cos theta is equal to tan squared theta times cos squared theta. Okay, so now after this we can cross out 1 cos here and cross out 1 cos here, so we'll have 2 over tan squared theta times cos theta. So now we can use the quotient identity again and isolate for cos theta, which is equal to sine theta over tan theta. So you can have 2 over tan squared theta multiplied by cos theta turns into sine theta over tan theta. So then if we cross out tan, 1 tan there, 1 tan there, we're left with 2 over sine theta times tan theta. So we can conclude that the right side is equal to the left side.
Now I'm going to show you how to solve this trig identity question using the conjugate. So first what we do is multiply the denominator, this side, the left side is the side that we're working with. We multiply it with the opposite, basically the conjugate of it. So 1 over sec theta minus tan theta multiplied with tan theta plus sec theta over tan theta plus sec theta. So now we get tan theta plus secant theta over secant squared theta minus tan squared theta. So now using the Pythagorean theorem identity, we can replace tan secant theta squared theta. So tan theta theta plus 1 minus tan squared theta. So tan squared theta plus 1 is equal to secant squared theta. So now we can just simplify. So tan squared theta subtraction tan squared theta. So tan squared plus secant over 1, because these two cancel out, is equal to the right side, which was tan theta plus secant theta. So therefore, you can say our left side is equal to our right side.
So now I'm going to teach how to solve by expanding. So here's a question that says cos theta times cos theta minus secant theta equals negative sine squared theta. First, you want to expand the brackets, so times cos theta to cos theta minus secant theta. So that's going to be cos theta cos squared theta minus secant theta times cos theta. And we're going to be working with the left side for this equation to prove that this equals to negative sine squared theta. So after that, you want to look at your rules for your trig identities, and you can see that secant theta is also equal to 1 over cos theta. That times cos theta. So now you have 1 over cos theta times cos theta. So that would be equal to just 1, because cos theta over cos theta, so anything over by itself is 1. Cos squared theta minus 1. And then you look at your rules again, your Pythagorean identity rules, and you learn that cos squared theta is also equal to 1 minus sine squared theta. So 1 minus sine squared theta minus 1. So you just rearrange the equation. 1 minus 1, which is equal to 0, minus sine squared theta. So you're going to be just left with negative sine squared theta, which is equal to negative sine squared theta. So the left side is equal to the right side.
Now we will solve using all of the identities. Alright, so this is the question we're going to start off with. Sine theta times cot theta plus sine theta times tan theta equals secant theta. Alright, so what we're going to do first is we see a cot over here. So sine's going to stay the same. Alright, but we got to change this cot. And to change the cot, we got to use the reciprocal identity. So over here you can see that cot equals into tan equals into 1 over tan, which is also equal to cos theta over sine. And now this is basically the same thing as sine over 1 times cos over sine. And then if we look over, we're going to continue. So it's going to be sine theta again, because that doesn't change into anything. And then we can see the tan over here. And we're going to use the quotient ratio identity now. And it's going to, tan is going to turn into sine theta over cos theta. So let's write that down. And now just like we did over here, we're going to do it over 1 because it helps us with multiplying. So this is obviously, I forgot to say, this is on the left side. So we're working on the left side, okay? So now when we multiply these two together, these two signs cancel out. And it's going to end up with cos theta over 1 plus, and then if we look over here, it's going to be sine over 1 times sine over cos. Okay, so that's going to equal to sine squared theta over cos. Okay, and we're still on the left side. And then if we continue that on, we're going to get to make it an equal denominator, we have to multiply this cos into the top over here to get it the same, and then this one into the sine, which won't matter. So we're going to do this cos is going to multiply into that cos, so we're going to get cos squared theta, and then we'll have the common denominator which we can add up. It's going to be, and this one is going to multiply into that sine squared theta, which is going to stay the same because it's just times 1. And then we'll have a common denominator, cos. Okay? And then if we go back to this sheet over here, we can see that the Pythagorean identity is sine squared plus cosine squared equals to 1. And so we can see that we have that right there. So 1 over cos. And over here we can see that we have secant, and secant is equal to 1 over cos, so that means beta. So now we can conclude that left side is equal to right side.
Man, Ishan, that video helped a lot.
Now we're gonna get 100% for sure.
Let's go. Oh,
Okay.
yeah.